Hello and welcome to my channel Flexomaster. Today we are going to study and learn about the continuous chapter Plastic Films in Packaging, chapter number 5, which is explaining various other films in packaging used, which are polyvinylidene, polyamide nylon 6, nylon 12, EthyleneVinyl Alcohol Copolymer EVOH, application in flexible packaging, medical packaging, food packaging, and poultry fish packaging. So let's start with the polyvinylidene chloride. Polyvinylidene chloride PVDC resin, the structure of which is shown here in figure 1.6 is usually a copolymer of vinylidene chloride with vinyl chloride or other monomers. PVDC is commonly known as Sarent. Application and uses: monolayer films for food wrap and medical packaging, co-extruded films and sheet structure as a barrier layer in medical packaging, and packaging of foods such as fresh red meats, cheese, and sausages. Coatings are often applied to prevent specific gas transmission. Polyamide. High molecular weight polyamides are commonly known as nylon. Polyamide are crystalline polymers typically produced by the condensation of a D-acid and diamine. There are several types and each type is often described by a number, such as nylon 66 and polyamide 66 Pa66. The numeric suffix 6 refers to the number of carbon atoms present in the molecular structure of the amine and acid respectively, or a single suffix if the amine and acid groups are part of the same molecule. Nylon 6. High molecular weight polyamides are commonly known as nylon. Polyamides are crystalline polymers typically produced by a condensation of a D-acid and a diamine. There are several types and each type is often described by a number, such as nylon 66, a polyamide 66 Pa66. The numeric suffix refers to the number of carbon atoms present in the molecular structure and amine acid respectively, or a single suffix amine and acid groups are part of the same molecule. Nylon 6. Some of the nylon 6 characteristics are outstanding balance of mechanical properties, outstanding toughness in equilibrium moisture content, outstanding chemical resistance and oil resistance, outstanding long-term heat resistance at a long-term continuous maximum temperature ranging between 80 degrees centigrade and 150 degrees centigrade, offer low gasoline permeability and outstanding gas barrier properties. Highest rate of water absorption and highest equilibrium water content 8% or more. Excellent surface finish even when reinforced. Poor chemical resistance to strong acids and bases. Films can be made by extrusion coating, and blown film. Polyamide films can be easily thermoformed and biaxially stretched. Application uses multi-layer packaging, food and medical, cover base, pouch, and solid films. Nylon 12. Nylon 12 has only one monomer, amine, aminoloric acid. It has the necessary amine group on one end and the acid group on the other. It polymerizes with itself to produce the polyamide containing 12 carbons between the two nitrogen atoms of the two amide groups. The properties of semicrystalline polyamides are determined by the concentration of amide groups in the micromolecules. Polyamide 12 has the lowest amide group concentration of all commercially available polyamides, thereby substantially promoting its characteristics. Number 1, lowest moisture absorption, B 2%. Good. Number 2, good to excellent resistance against greases, oil, fuels, hydraulic fluids, various solvents, salt solution, and other chemicals. Number 3, low coefficient of sliding friction. Number 4, lowest strength and heat resistance of a polyamide unmodified. Application: Grilamide L25 is used for sausage skins for pre-cooked sausages, and packaging films for deep frozen goods. Now come to nylon 66. Some of the nylon 66 characteristics are as follows. Outstanding balance of mechanical properties, outstanding toughness in equilibrium moisture content, outstanding chemical resistance and oil resistance, outstanding long-term heat resistance at a long-term continuous maximum temperature ranging between 80 degrees centigrade and 150 degrees centigrade. Offers low gasoline permeability and outstanding gas barrier properties. High water absorption, poor chemical resistance to strong acids and bases. Application and uses: packaging meat and cheese, industrial end uses, pouch and primal bag, stiff packages, snacks, condiments, shredded cheese, and coffee. Also used in wrapping, fine art, potable water, and electrical application. Another nylon 6 by 12, 6/12 is another kind of nylon, which its characteristics are high impact strength, very good resistance to greases, oils, fuels, hydraulic fluids, water, alkalis, and saline. Low coefficients of sliding friction and high abrasion resistance even when running dry. Heat deflection temperature, melting point nearly 40 degrees centigrade, higher than nylon 12. Tensile and flexural strength, outstanding recovery at high wet strength. Application: multi-layer food packaging and boil-in bag. Now we come to ethylene-vinyl alcohol copolymer. It is called EVOH. EVOH is a copolymer of ethylene and vinyl alcohol. These materials are highly crystalline and are produced with various levels of ethylene content. EVOH film has many desirable properties that are summarized as follows. Anti-static properties: since EVOH resin is a highly anti-static polymer, dust is prevented from building up on the package when used as a surface layer. Luster and transparency: EVOH resins produce a high gloss and low haze, resulting in outstanding clarity characteristics. The uses of EVOH resin is as outer surface of a package, provides excellent sparkle for improved package appearance. Printability: with an OH group, it is in its molecular chain, the EVOH resin surface can be easily printed without special treatment. Resin to resistance to oil and organic solvents: EVOH resins resist oil and organic solvents, making them particularly suitable for packaging oily foods, edible oils, mineral oils, agriculture, pesticides, and organic solvents. Weather resistance: EVOH resins display excellent weatherability even when exposed to outdoor conditions. The polymer retains its color and does not become yellow or opaque. Mechanical property changes are minimal, demonstrating an overall high resistance to weather effects. Here is the figure showing different layers: plastic sheet, adhesive, EVOH, adhesive, PE, and plastic. It is possible to laminate many materials with EVOH. Again, it is the characteristics continues. Preambility: EVOH resins offers outstanding gas, oxygen, carbon dioxide, nitrogen, and helium barrier properties and maintain their barrier properties over a wide range of humidity. The oxygen barrier properties of EVOH vary according to the ethylene content in the polymer. Packages containing EVOH resins can effectively retain fragrance and preserve the aroma of the contents within the package. At the same time, undesirable odors are prevented from entering or leaving the package. Film processing methods include monolayer film extrusion, blown or cast, co-extruded film extrusion, blown or cast, co-extrusion, blow molding, profile extrusion, and coating. Application and uses: rigid packaging for entries, edible oil, juices, cosmetic, pharmaceuticals, heating pipe, automotive, plastic, fuel tanks, and packaging for condiments and toothpaste. For flexible packaging application, processed meats, bags in box, red meat, cereal, pesticides, and agri-chemicals. There are many applications in flexible packaging. Packages may be formed in line by several techniques or may be supplied to the packer as preformed pouches or bags. Packaging may be created by wrapping or shrinking a basic film around a bundle of goods. Inline packaging forming example including vertical form fill seal, horizontal form fill seal, and thermoform fill seal machines. In vertical form fill seal operation, film from a roll is guided through rollers and then shaped by a forming collar into a tube. Markets for flexible packaging films have continued to grow in many applications. Polyethylene and the various copolymers account for more than 75% of the flexible packaging film. Some major market segments where co-extruded film is used, including the following: medical packaging, food packaging, heavy-duty shipping bags, stretch wrap, trash bags, condiments, OPED, print, LDP, LDP and variation, it's laminated with several materials, aseptic packaging, juice boxes, and toilets, condoms, similar structure as toilets, laminates for toothpaste tubes, PE film, LDP, LDP, PE film, stand-up pouches, OPET, print, then adhesive, then OPP, adhesive, then LDP, HDP or LDP, and very many variations. Medical packaging. Medical packaging, a wide variety of structure are used in the medical packaging area. The structure requirements include sterilization capability, microbial barriers, linear tear properties, puncture resistance. Sterilization methods used for medical packaging film include ethylene oxide gas or radiation. The package is typically a forming web and a non-woven fabric like Tyvek and lets the ethylene oxide in and out of the package. Medical packaging usually does not require oxygen barriers, so EVOH is normally not required in medical packaging structures. Co-extrusion processes are growing in this market. Blown film, cast film, extrusion coating process are used in producing flexible packaging structure. For medical packaging application, films ranging from 3 layers to 11 layers are now available. These markets are typically small and require many years to meet the required qualification. The forming web are historically 3-layer EVA and ionomer films as shown in the syringe package in the right in the figure. Heavy gauge films are sometimes produced by combining a 3-layer film or form 6 layers. Newer films structures have seen more layers being used in incorporating PA to replace ionomer in film structure to address food packaging. Primal meat packaging shrink. Packaging primal and subprimal meat requires a package that must provide high shrinkage to fully collapse around irregular shapes, have excellent optical properties, shrink at low temperature to prevent product damage, impart good softness and elasticity, provide excellent oxygen, moisture, odor, and grease barrier protection, prevent freezer burn, facilitate using individual cuts by food preparers, help reduce purge loss, extend shelf lives, offer easy disposal, have good machinability, have an oxygen transmission rate OTR less than 1 centimeter per centimeter cube, 100 in 1, 2-day ATM, non-frozen only. A shrinkable film used in the application is PVDC, barrier film, and the sealant layer designed to provide toughness and puncture resistance. These films must be oriented to provide acceptable shrink properties using a double bubble process. Poultry fish packaging. Moisture barrier properties are more critical. The packages are normally vacuum packaged with a good sealant polymer such as EVA, ionomer, or LLDP. And accordingly, we will continue for our chapter number 6. And I thank you very much for watching this video, and please share your comments and subscribe this channel and learn more and more. And the coming topics, again, we will continue for plastic films and packaging. And looking forward to see you again. Thank you very much and goodbye.